In this lesson, we're going to review scientific notation and standard notation. This problem is originally given to you in standard notation. That's how you're used to seeing problems given. And if you remember doing scientific notation before, that is when you are trying to write the number really big numbers or really, really small numbers in a more compact way. So for this example, my decimal point is right here. We don't draw it in. But to move a number to scientific notation, I want it to be a number between 1 and 9. So I'm going to move the decimal to make this a number between 1 and 9. So hopefully you would see that means I move the decimal right here. So my answer would be 6.38. And then every time I move a place value, I'm moving by a power of 10. Timesing by 10 is what gives me my place values. 10 times 10 gives me the next place value. You keep going on forever. So in scientific notation, you would say 6.38, and I drop the rest of the zeros, times 10 to the, and I count how many place values I moved. You can count, some people will have you count each one like this. I just say do your decimals like this and count how many numbers are between. Since I have 6 numbers right here, that means that I'm multiplying by 10 to the 6th. I move 6 place values. So in scientific notation, this number is 6.38 times 10 to the 6th. The second one then is a really small number. So I'm moving the other way for place values. And again, I'm making the number between 1 and 9. So I put my decimal right here. So 4.7 times 10 to the, and when I move to the right, I'm moving negative place values. They consider that. So I'm going to be counting how many numbers are between, which is 5, and I'd be to the negative 5th power. And hopefully that's a good enough review. You've done these in science classes before, and you also did this a little bit in Algebra 1, so hopefully that comes back to you. What we're going to do that's using our exponent rules is we're going to multiply two numbers that are already in scientific notation. Sometimes people will bring them out of scientific notation and put them into standard and then multiply them and put them back into scientific, and that's not necessary if you know your rules for exponents. So to multiply numbers that are both in scientific notation, I take the number out in front and I go ahead and multiply them. So 4 times 2 would give me 8. So my answer is going to be 8 times 10 to the, and this is the same base. Just like if I took x to the 5th times x to the 7th, I'd get x to the 12th. These numbers both have a base of 10. So I want to keep that base of 10 because I'm in scientific notation, but I add those exponents. So my answer would be 8 times 10 to the 12th. Number 4, you'll see we have some decimals we're multiplying. So 2.8 times 3.9, I would get 10.92 times, and I'm going to go ahead and add these again, so times 10 to the 4th. Now what's tricky about this is sometimes what happens when you multiply or divide two numbers in scientific is during that multiplication or division, you all of a sudden end up with a number that's no longer in scientific. Remember, in scientific notation you want to have a number between 1 and 9. This number is 10, 2 digits. We need to have a single digit. So I have to actually move this number back into scientific when I'm done. So I would have 1.092, and then I moved it one more place to the left there. So I'm going to have one extra digit there when I add it. So think if we multiplied these out, let's think of this number, 0.028 is that first number, and the second number is 3, 9, and 5 zeros. So 3.9 million. So let's think if we actually multiplied those two on your calculator. That's what you'd probably do, right? So I'm going to punch in 0.028 times 3.9 million. I get 109,200. So now to put this in scientific notation, this decimal's here, I'd move it all the way here, so I'd have 1.092 times 10 to the 5th. Do you see that? So in this problem, a lot of times students aren't sure which way to move. When I move to the left, just like here, when I moved to the left, I was going this way. Notice that I had a positive exponent. So in this one here, when I move to the left, I'm going to add 1 to that exponent. So it's going to be 10 to the 5th. If I would ever have to move to the right, I would take an exponent away from that. So I just wanted to show you how that actually works here by doing it the long way. This is actually what we're trying to avoid, but I wanted you to see which way that decimal moves. So now you can see that you'd add 1 there. The last one we're going to do then is division. In division, I take and divide my numbers like I always would. 6 divided by 3 is 2. Now if that happened to not divide evenly, I would just use the decimal value. And then it's going to be times 10 to the, and what's different about this is when I'm doing division with my exponents, I can say bigger X top or bottom. In scientific, I have to pick the top because I can have negative exponents in scientific. That's the only type of problems you can give negative exponents as an answer for, is when you're in scientific notation. So I'm going to actually have to take negative 3 minus 1. So I would get negative 4. And there's a review on scientific notation.